Yesterday we finished, what I did yesterday is I went through all of assignment 3. Now, normally I don't do that in a regular class, as you know, if you've been coming regularly before school suspension. But due to the circumstances, I thought that, and because this is such a kind of a complicated undertaking to try and do the Applied 30, we're just starting to learn the technology. So it's kind of a challenge, I know, but hopefully hoping that you're following along still. And I'm just going to try and move this over a bit. You do need the graphing calculator, right? Which is why I was trying to impress upon people to took a copy of the program on their flash drive, or they knew how to get it from their Android phone. I didn't receive any questions in the form of emails, so I'm assuming that people are following along and, continuing through the book and hopefully working through either using the app on your calculator or on your phone. So we're going to start lesson 4. And we're just going to keep going on, like I said. And I guess if you do have questions or comments, I do have a resource period at 10 o'clock that you can I post the link on my blog and you just click on it. Today I was unavailable because I had to go into school, but normally I'm available so you can ask questions live. So 10 to 11 every day. And perhaps tomorrow, I'm thinking maybe tomorrow I'll have a work period. Talk about identifying characteristics of linear functions from a given graph. So what a linear function is, it's just a line, right? It's a straight line. So these are all important words, vocabulary words that you need for this unit. Leading coefficient, slope, end behavior, y-intercept, x-intercept, domain, and range. So the first thing is equations that have straight line graphs are called linear equations, okay? Linear equations, straight lines. And it makes sense, right? If you look closely here, inside that word linear, there's the word line, right? Now we've been talking about graphs pretty much this whole unit. Display a relationship between data, right? And data is just a bunch of quantitative data. Quantitative means heart rate or heartbeat of something, or oxygen levels, or how much the water rises over days. I mean, that's something that's concerning Manitoba right now. We hope that we don't flood. So when we study something over time, we generally can assign a number. So in the case of the water level of Winnipeg, people concerned with flooding are monitoring how rapidly the river is rising, right? So they measure the river levels, so those are two things that you can put to numbers. When you collect enough numbers, you can create equations like we've been doing the last couple of days, and those equations can also be put into a graphing program and create a graph. We learned how to create graphs by hand, creating graphs with technology. And by technology, I mean our graphing calculators, right? So once again, equations have straight line graphs. They're called linear equations. And I need an equation to put into the graphing calculator, or I can develop an equation from raw data, like we've been doing for the last couple of days. Sometimes they're also called linear functions, okay? We can determine a lot of information about the graph of the function just by examining the equation. In the previous lesson, we saw that we could determine an equation if we were given a table of data. We could use that equation to answer questions about the relationship. We now move on to questions where we are given the equation, okay? There is a lot of information we can determine about the relationship just by studying the equation as well as looking at the graph, okay? So now, what we're going to do is we're not going to be given lists of data. We're just going to be given the equation. So here we go. Here's today's new stuff. if we are given an equation, if we're just given the equation already, we can enter it into the calculator. Now, do you remember for the last couple of days, if I just refresh your memory, what we did is we did stat edit, right? We entered a whole bunch of stuff into a calculator, the vars, right? This is everything we've done for the last couple of days. So I got the equation. I had to substitute the A and the B value into the equation. And then it also, what happened was it plotted my data points, it created a line, and it also pasted something into that y equals screen, okay? So the reason that you saw this line develop is because there was something in the y equals screen, the y1. So what we're gonna do today is we're not gonna have raw data. We're gonna work with questions where they already give us the equation and we just put it right into the y equals screen, okay, right here. So the first thing I'm going to do, you saw that I had some raw data in here. I'm going to clean my calculator up. Second, in the plus sign, number 7, number 1, number 2. And then I get that RAM clear, the day fresh. Okay. So starting on page 19. If we are given an equation, we can enter it into the calculator. We just press the y equals key, and it gives us the following calculator screen. Now, remember I said at the last week that all the graphing stuff we need is in this top row of gray buttons. The next section says, to graph the straight line y equals 2x minus 3. So this is what the equation of a line looks like. We make sure the cursor's in the correct position beside the y equals, because I can actually graph 7 different lines, right? We're only going to graph one line today. So I want to graph 2x minus 3, right? This is like your A value, right? And this is your B value. So I press hopefully you can see this, just up a bit. 2, the X is here. The X is by the stat button, and just press the X there. Minus 3, okay? So that's it. And again here, if you forget to use the X, use the green. Okay. All right. So now let's see what they ask us to do. I'm going to see if I can move this, if I can have a calculator screen and the notes at the same time. There. That seems to work, right? Okay. Press the graph key. So as soon as I press the graph key, you're going to see a line forming, right? That little line that was going through our dots. So that's the same type of line we were creating with raw data, because when we do all those steps on page 13, that creates the line going through our data, and then it puts something into our y equals. As long as there's something typed into the y equals, either by you or by you using the steps from page 13, as long as there's something in a y equals, you're going to see a line on your graph, okay? So we press the graph key and you should see the following. Now, remember, it shows you lots of time. In the last unit, we were doing lots of stuff just on quadrant 1. Here it's showing us all 4 quadrants. It's showing us the x-axis and the y-axis, right? Slants across the screen. This is a positive correlation, right? It's going up. If we press trace, the screen kind of changes. So if I press the trace button, we've seen that button before. If I press trace, you can see that then I get more info, right? And it's giving me a lot of info. This is called the cursor, the little pulsing point. The cursor is pulsing on a point on the line where the line crosses the y-axis, right? So it's pulsing here. Just going to put a little asterisk. So it's pulsing right here. And when you press trace, it actually automatically just puts itself on the y-axis. This is actually called the y-intercept. Notice what it displays down here. X is 0, y is -3. It's pulsing. This is the coordinate point 0, -3. Okay, this is where, and this is telling you right down here, x is 0, y is -3. Points that fall on the x and the y-axis are quite important to us. Now, this is also something interesting if you look down at the next paragraph. The calculator automatically creates a table of values when an equation is created. As soon as I put an equation in the y equals, or I paste it in using the steps that we learned in the last lesson on that page 13, as soon as there's a y equals in here, however it comes, there's automatically a table of values created, okay? And you can view the table by pressing second graph, okay? So this is my graph button, right? But right above the word graph is table, so it's in blue. I press the blue second button and table. And inside the calculator, a table of values has been created, right? X, Y values. So that's really, these are all the points. These are all the coordinate points on this line. All right. Okay. So next page. Now, as we said earlier, if you look back here, we wanted to talk about all these words, right? Leading coefficient, slope, end behavior, et cetera, et cetera. This is what we're talking about here, right? So I've got my screen. I'm just going to press trace again. So to still have these guys here. And notice when you press trace, it actually puts your y equals, whatever you put into your y equals screen right up here too. So that tells you what graph you're seeing, right? This is the equation, this is the picture. Now, as we move left to right, the slope, it's rising, okay? So that's what we say, the slope rises to the right, okay? And I just want you to remember as we read the graph, I'm just going to have to move this down a bit, sorry. From left to right. Okay? And that's how we read our graphs, just like we read our text from left to right. The sign of the leading coefficient is positive. Okay, I want to write this down. 2x minus 3. Okay, this, the number attached to the x, this is called the leading coefficient. And we learned this in the polynomial section that we did. Okay, so whatever number is attached to the first x that appears, like the highest power of x, that's the leading coefficient, all right? The end behavior, well, it's from quadrant 3 to 1. Remember, this is quadrant 1, and then we move around counterclockwise. That's quadrant 2, quadrant 4. They're using Roman numerals. I'm just using Arabic numbers. So if I read my graph from left to right across the page, it's it's starting in quadrant 3, right? Left to right, and then it's moving up to quadrant 1. There's actually arrowheads, right? Because this line goes forever. So that's what it means. It's going from, it starts in quadrant 3 and it moves all the way up to quadrant 1. So now the domain and the range. Let's talk about domain and range. I'm just going to move the page up a little bit. A domain is a list of all the possible x values of a function. Inspect the side-to-side growth of a graph to determine its domain. So the domain is all the x values. So because this is my x-axis, right? And this is my y-axis. If I look at how the graph grows side to side, like along the x-axis, you can see that this graph is growing. Most students would say it's growing up and down, and it is, but it's also growing. It's pointing kind of to the right, and it's pointing to the left. So it keeps moving. It's going to keep growing and growing all along, like it's crawling along the x-axis too. So it's going to, this part of the x-axis is infinity, positive infinity, right? This part of the x-axis is negative infinity, so it's growing towards negative infinity. So there's no boundaries to the domain of this graph. So we say X is an element of the real numbers, right? So the domain has no limits. That's what that means, XCR. So it grows from negative infinity to positive infinity. Now, the range is all the possible Y values. Inspect the up and down growth of a graph. The domain is also all real numbers, or sorry, the range is also all real numbers. The range has no limits. This capital R, XER, means, literally translated, means X can be any real number. And similarly, YER, this is the Greek, it's like a capital E. It means Y is an element of the real numbers. That just means Y can be any real number. Any real number. Okay? So for linear functions, there's no, like the growth is just unrestricted. This graph, this line grows up and down to infinities, but it also goes sideways to infinities. If you can kind of stretch your mind and see that, it's all, it's not just growing straight up and down, it's growing to the right and it's growing to the left. So that there's no boundaries. And that's what this says here. For linear functions, because both possible values of X and Y are limitless, both domain and range are set of all real numbers, and we represent it like this. This is really important though. However, be aware that when we use a linear function to model a real world problem, sometimes the domain and range are restricted. So that means when we do some real word problems, assignments, it might not be, we might just be using the linear function to model something, but it might end up being just a quadrant 1 problem. So if it's a quadrant 1 problem, like we saw in the previous assignment, we were using a line to represent the problem. If I just flip back for a moment, like for example, we used a line to sketch the year and carve the way cutting through, and it would have grown infinitely. But we know that year, we can't have negative time, we can't have a negative amount of money for car sales. So we were restricted to quadrant 1. That's what they mean by this. We might be restricted. We might be restricted to quadrant 1 for some of our problems. Okay. All right, let's try an example. Analyze linear functions when we were given the equation. Okay, so all we're doing is we've got the equation y equals minus 3x plus 5, right? So let's enter that into our calculator and see what we've got. When I go to my y equals screen, it's all blank because I cleared it out. And I'm going to enter in negative 3x plus 5. Remember, your negative button is down here. This is the subtract button. This is the negative button. Negative 3x plus 5. Okay, when I take a look at the graph, I see this picture. Okay, so that's what I'm going to reproduce here. It's a line slanting downward. I'm going to hit trace again to see what I see. There's my equation. And here, this point is 0, negative 5, or sorry, 0, 5. So this is the coordinate point, 0, 5. Okay, I'm just going to put that there. Now, remember when we used trace before and we were using trace to move up and down the line? Let's see if I can figure out what this point is. And it doesn't give me an exact value, so I'm going to move back there. Okay, The slope direction, as I move from left to right, as I read the graph from this side to this side, if I start here, it's moving down, right? So it falls down. It doesn't rise, it falls to the right. Okay, instead of rising to the right, it falls to the right. Sign of the leading coefficient. Okay, so this is the leading coefficient, remember? It's the number attached to the x. This is the leading coefficient. So it's negative. The end behavior, well, let's see. As I read the graph from left to right, the end behavior, well, it started in quadrant 2, right? And then it moved down to quadrant 4. So I say quadrant 2 to quadrant 4. Now, for all lines, unless you're restricted by a word problem, my domain is going to be x can be any real number, y can be any real number. Okay. All right. I see someone's watching, but no questions so far, so I guess I'll keep going. Okay, let's try this next one. Draw a sketch of this function, y equals negative 4. All right, so y equals negative 4. There's no x in here, right? It appears to be missing. So that's okay. I'm going to grab my calculator again. By the way, I'm going to always go second plus sign, number 7, number 1, number 2, clear everything out. So when I clear everything out, if I press graph again, I would just see a blank Cartesian plane. So I'm going to go into my y equals. This time there's no x to enter in. That means it was 0x to be honest, but I'm just going to put a negative 4, right? Remember your negative sign's down here, 4 is here. Now when I press graph, I get a line going right through. Let's see what trace says. 0, negative 4. So this is where y equals negative 4, but this is what the picture would look like. It's kind of funny. So when the x is missing, I'm just going to write you a little note here. This is actually the equation y equals, when x isn't represented, it's actually the coefficient is 0, 0x minus 4. But we don't write the, if it's 0x, there's really no purpose in writing it. So that's why it just appears as minus 4. But just remember the leading coefficient was actually 0. And that has implications later on when we talk about slope. All right, describe the end behavior and the slope. So the end behavior, what quadrant is this? Well, this is quadrant 3, quadrant 4, right? So we would say end behavior is quadrant 3 to quadrant 4. And the slope, when it's a flat line, this is a flat horizontal line with, now we say the slope, there's no slope. Slope is the amount of incline. So 0, it's just a slope of 0. Okay, this equation has a leading coefficient of 0. Explain why. Well, I kind of think we did already, right? The equation is actually and then anything multiplied by 0 just becomes 0 itself. So that's why the term disappears and it ends up being simplified. This simplifies to y equals -4, right? That's why the 0 times anything is 0. So it ends up just being -4. Y equals -4. Okay, still don't see any comments. So again, if you have comments later, if you're watching this later, you can always comment on email. And I can answer your questions either during a live stream or during a Google Meet session. Okay, I'm going to flip over. Let's take a look at example 3. And then I'm going to give you tomorrow's class to work on assignment 4. And like I say, I'll open up a Google Meet link so you can ask me questions during the class. And we'll just have a work period tomorrow. So sine of the let's just summarize here. Sorry, let me flip back for a second. What I hope, I'm not sure if we did enough examples, but when we had a positive leading coefficient, notice the graph moved up, slanted up. When it was a negative leading coefficient, the graph slanted down. When it was a 0 coefficient, 0x, the graph was straight across. So those cover all 3 cases. So let's take a look. Use a graphing calculator to help you analyze each. So I'm going to clear my calculator out. Okay, so now when I go to y equals 0.5x, so 0.5x plus 4 graph. So it looks like it's kind of a more shallow graph. It doesn't go as high up on the y-axis. So let's press trace and it goes to 4, right? So it's kind of a flat thing here, there. Sign of leading coefficient is positive because the leading coefficient is 0.5. That's a positive number. Slope direction rises to the right, up, and I can just say up, maybe, it slopes up. End behavior, well, this is quadrant 3, quadrant 1. So quadrant 3 to quadrant 1. Okay. Next one. I'll show you another quick way to clear, like just if we're just putting a y equals in, we can just hit clear like that too. So negative 2.2x plus 12. Notice this is a negative coefficient. So when I press the graph, it's doing exactly what I expected, right? It's dropping. Okay. So let's do this. Leading coefficient is negative, and it drops to the right, meaning when I move from left to right, it's dropping down. We can also say it's a downward, right? Down, it's moving down. So this one, even though my graph doesn't show it, it's actually growing and growing and growing. So this graph actually started in quadrant 2 and ends in quadrant 4. Okay. This one, a constant. We've seen this before, right? I'm going to go to my y equals, I'm going to do it, right? So right across the page, sign of the leading coefficient, there is none. The leading coefficient is 0. Okay? It is not positive or negative. 0 doesn't have a sign, it's neutral. So this is, remember, this is actually y equals 0x minus 5. Okay, slope direction. I'm just going to say slope is 0. End behavior, well, it does have an end behavior, right? Quadrant 3 to quadrant 4. So here we've got an interesting equation. These two equations have brackets in them. Now, remember that this 1/3 x, a negative times a negative is positive, 1/3 times 1 stays 1/3, right? So that shows you it is a linear equation. It does have an a and a b value, but even though you know how to do that, you actually don't have to multiply through. You could just enter it in bracket form. And I'm going to show you, I'm just going to do my quick way. You can just enter it in like -1 divided by 3. So again, -1 divided by 3. Press your bracket sign. X subtract 1, close bracket. Your calculator is very powerful. It recognizes exactly what you want. So it actually is doing the multiplication out for you. So you don't have to translate it into a proper linear form. Press graph. Again, we kind of got to really grab it. Almost looks like it's going through the origin, right? Not sure if it is. We'd have to do a little bit of deep diving and a little more research. Okay, so let's do this. It's a really shallow. Whoops. I think I should get a little closer to the origin. Okay. So either way, now maybe you might want to multiply it through to see your coefficient better, but either way you can see if I multiply this through by x, my leading coefficient is negative, right? Because the leading coefficient is the negative 1/3. Slope direction falls to the right. End behavior, quadrant 2, quadrant 4. This one, I'm not going to bother. I can see that the leading coefficient will be 3, right? Even if I don't multiply through. So it's positive. And even without graphing, if it's positive, I think and it's right down here, right? But it's still rising up. So we're just going to kind of record what we see. It will eventually cross the y-axis, right? So I'm just going to I'm going to draw it like I see it. This is how I see it. So slope direction rises to the right. Now this is interesting. What quadrant? What is the end behavior? Even though our calculator doesn't show it, I hope that you can see. If you drew the line down further and further, remember how we were changing the windows? If I wanted to change my window and I want to see more down in the x min, like if I put a 50 here, whoops. That's x max, right? If I put a -50, okay, eventually you can see this is the same graph. It does cross the y-axis. So regardless of if it shows it, this line is going to keep growing and growing and growing. So it does start in quadrant 3 and it ends in quadrant 1. And then this last graph, can you see they kind of did something sneaky? They put the x term at the end and the 3 in front. This is actually the graph of -4x plus 3. So don't be fooled. Whatever number is attached to the x is your leading coefficient. I'm going to circle this in red. This is actually the leading coefficient. So the leading coefficient is negative. Now, I'm just going to do the y equals clear. Even if I enter it like they give it to me, 3 minus 4x, right? And I press graph. Whoops, sorry, I should have put my grid back normal. See, the graphing calculator is super smart. It's not going to be fooled by the order. It changes the order, right? And you're going to get this line coming down. So you can either enter it like this, or you could enter it with negative 4x plus 3. But you can also just enter it always just like it's given to you. The calculator is smart enough to know which is your A value and which is your B, right? This is your A value, that's your B. So the graph is a slanted down, which we recognized it should be because it's got a negative leading coefficient. So falls to the right. Once again, this is quadrant 2 to quadrant 4. I wanted you to take away for this whole lesson, to be honest. Take a look at the leading coefficient. A line is by convention, a line is written in this form, right? AX plus B. That's what we learned from our graphing calculator in the last lesson. This is whatever number is multiplied by the x, that's your leading coefficient. So your leading coefficient, positive, positive. If it's positive, the graph rises. Leading coefficient negative, negative, drops down. This one's, there is no leading coefficient other than 0, so 0 is just a flat line. Negative leading coefficient drops. Positive leading coefficient rises. Negative leading coefficient drops. You got to look close sometimes for the leading coefficient because it's the number attached to the x. Now, also, all the graphs that rise, sorry, it's just these two, I guess, these two graphs that rise, it's always quadrant 3 to 1, right? 3 to 1. So notice the positive graphs 3 to 1. If a graph falls, it's always 2 to 4. So negative, 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 2 to 4, 2 to 4, 2 to 4. So certain patterns develop, right? You can learn a lot by just looking at the equation before you even touch your graphing calculator to graph it. You can actually understand a lot about the equation. So that was kind of a long class. There was a lot of talking I had to do. So I'm going to give you tomorrow's class to work on assignment 4 just time. And then I think we might start number 5 as well. But actually, you know what? I think I've changed my mind. Never mind. Sorry. Do assignment 4 for homework because it's not that long. That was longer. So do it for homework. And then we're going to start lesson 5 tomorrow. And I'm going to give you work time on Thursday. So I'll end the stream today. And then we will keep going.